All right, cool. I think we're good to get started. Thank you everyone for coming today. This is the Graph Builders office hours. As you guys all know, we meet every Thursday at 9 a.m. Pacific. And really excited today because we have Mack from the Graph Builders DAO and from Graphica that's going to be talking about transaction receipt usage. So very, very excited for that. As you guys all know, this is going to be recorded, so this will be uploaded to YouTube. Just keep that in mind. And feel free to use the chat to ask questions. We're definitely eager to hear any questions you have or anything you want to hear about today. Just let us know. But without further ado, Mack, I'll pass it up to you. And thanks again for being on here.
Good morning, everyone, and good evening for those also in similar time zones to myself. Today, we will be running through transaction receipts on event handlers. So this has been a feature that's been around for quite a while, but it's not technically old, right? I've been using it on and off for quite a while, but recently I've really tried to make the most of it. So we'll be essentially jumping into some ways that you can use it to essentially add more data and infer more data in your subgraph. And also some other exciting examples. So let's jump in. And feel free to ask any questions. I'll pick them up as they come in. So transaction receipts, right? This is a feature flag which was added to event handlers. And essentially what it does is it hydrates the object on the event object, the event.receipt object with a transaction receipt object. Right, we can see the transaction receipt object down here on the right, and you essentially will have access then to all of these data points. Some of them are more useful than others. I mostly use the logs, but you can also use something like the contract address. So just a little bit of boring stuff. This requires a spec version of 5 and up, or add an API version of 7 and up to use it. And to turn it on, you essentially just put receipt true on your event handler. Cool. So we got that out the way. Give a thumbs up if you use transaction receipts in the chat, or if you have used it in your subgraph. You don't have to do it right now. Oh, there you go. So why are they so useful, right? So it essentially gives you more access to more information. We are very data hungry when we're building subgraphs, and when we're indexing, the more data, the better. Without impacting things like sync speed and also just code volume. So the more information we have, the more data we have, the better. And this essentially allows you to get basically the full transaction and all of the information that happened on the transaction where your event was emitted, right? So if you have a transaction and you're tracking X contract and an event on that contract, this would essentially give you access to all of those other events and some other good information. So really, I want to focus more on the events that you get access to. So if you take a transaction and you have access to all of the other events, you can do a little bit of magic, right? So the other events are stored on the log array or the logs array on the receipt, and this will include anonymous and verified contract events. So it doesn't matter whether the event doesn't have a name and doesn't have its parameters decoded, and to find the log that you're looking for, you essentially will just iterate over the log array and essentially try and match on the topic 0 and the topic 0 is just a SECAC hash of the event signature. And when I say the event signature, it will just be like below the example, it would be stack delegated open bracket address, comma, UN256. I'll double check. I don't think you do need to include whether it's an index topic or not. And that would essentially produce the same as the topic zero. Why I mention that is because if there are unverified contracts and you are looking for a specific event and you know what the event signature is, but you're looking at a transaction, you're like, this is not verified, you can use that method to kind of find it. Cool. So the use cases, one of the simplest use cases where I started using it was if I have an NFT subgraph and, I'm tracking the transfer event, obviously, because, in the transfer event, you can infer things like mint, you can infer things like burn, whether it's going to or coming from the zero address. But outside of that, it's just pretty much going from a EOA to another EOA or an EOA to a contract. And maybe you want to infer more data about those transfers, right? Without adding tons more data sources. So if you wanted to know whether it was a sale or not, and not just a standard transfer, what you could do is, instead of adding the data sources for something like OpenSea and Blur and those other markets, which would quickly balloon your subgraph, into a really, really big monster. Even if you're not creating entities in those events on OpenSea and Blur, just you can't. There is no way currently to reduce the amount of events that are just for your contract. So it would still, fire that handler on the OpenSea and Blur data source tons and tons of times. So that is not a very efficient way to do it. Rather, what you could do is look through the events and see if you can find the specific sale event on OpenSea, which I think it's auto-matched, and then the same thing on Blur and whatever other marketplaces you want to add in there. And this is essentially just a for loop, which runs over all the logs on the receipt. And then you just put a bunch of if statements. If you want to use a switch statement, you can. In Substream world, we just, do a match on that. But you essentially will just gather those topic zeros. You'll say, if the topic zero is this, then you know that there is an OpenSea orders match. Same with Blur, those sorts of things. Just showing a quick example. I'm part of the Revival team for this NFT collection, doing very well. That's a shameless plug. But this Trump Pepe recently sold for a whopping 2.9 ETH, which is the highest sale that has happened since we revived the project. And to use that as an example, here is the transaction for when it was sold. You can see here it's coming from, this is the person buying it, and it's interacting with Seaport 1.5, and this is the seller. And you can also see that there is a fee transfer of 2.5% to OpenSea, as well as 2.5% to the royalty contract, the royalty address, right? So looking at the logs, you can see here that I have a transfer on my tracked Crypto Pepe's contract. So, the subgraph for Crypto Pepe's will obviously be tracking this transfer. And an easy way to infer whether it was a sale on OpenSea is I could just match on this topic zero, and I've already decoded the correct data point. So you can see here is the person purchasing, here's the purchaser, here's the contract of the Crypto Pepe's, here's the token ID, here is the total amount going to the seller, which is this, and here is the fee to OpenSea, the Seaport, the OpenSea fees contract, and here is the fee going to the royalty wallet for the collection. So, just have to iterate over those logs, match on topic zero, just this string. You just convert the string to bytes, and you match it on topic zero, because topic zero is bytes. And if it finds that, you're happy. You can even go a step further, and you can say, if it matches on topic zero, and this data point over here is the same as my address, my data source address, then you know for damn certain that it is it is a sale for that crypto. Again, you go a step further and say, my contract and this token ID, which will also match to the event.address as well as the token ID inside of the transfer. And that's what I would do, is essentially match on that, the token ID, and even go as far as to try and match on the to and the from as well, because those are also present with inside of this event here. So that's a very very easy and attainable implementation for most subgraph developers, right? And it's an easy add that most people can do. What if I told you it could really optimize your code as well and increase sync speed, right? So now we're getting into the real meat of the talk. So recently, myself and Derek from the BuildersDAO have been doing some intense work going through the Uniswap subgraphs and really just working on optimizing it and like best practices and seeing where we can do as much as we can to make them better. And after reading the code for a couple of hours with Derek, we were like, okay, cool. There's a sync event, there is a mint event, there's a burn event, and there is a swap event, right? And those are the most important ones being emitted on V2. But if you actually go look at the code in depth, you can see that just before the mint, there is an update function called. What does update function emit? It emits sync. Okay, cool. Just before the burn is also update. Cool. Just before the swap is also a sync. So using that logic, we decided to essentially go the route of removing the mint, the burn, and the swap, and really just focusing on the sync. So, and this looks like something like this, right? And I'll also go through some of the gotchas that you need to look out for when dealing with receipts. The receipt is a union type, which means it can either be null or a transaction receipt. So it's always good to, assign it to an in-memory variable, check for whether it's null or not, and then move forward, right? Easy. Next is always good to also check if the log length is more than 0. Obviously, it always will be because an event is being emitted, but c'est la vie, probably remove that. And then we start iterating over the logs, right? Also, I also like to basically put that into memory, the log length. And then we start iterating over the logs. And one of the very, very important checks is to always check if your log actually has topics, because there are events that sometimes don't have any topics at all. This is kind of cropped up a couple of times. It sounds like it's impossible, but it has cropped up a couple of times for us. And then you just make sure that it's more than 0, and then you can start doing your checks. So here you can see that I am doing a little bit of an extra check to see, is the log index one more than the sync, because this is the sync event. And as we established here, sync happens and then right afterwards swap happens, or sync happens and right afterwards burn happens, sync happens, then right afterwards mint happens. So we essentially say we expect the log index to be 1 more. This essentially makes sure that we're getting the actual next event after the sync, right? So it'll be, we if there possibly is a mint, burn, and a swap in the same transaction, we don't want to pick up, the wrong event. We want to pick up the one after the sync. So if there is a mint and a burn and a swap, it'll be sync, mint, sync, burn, sync, swap. But we don't want to pick up, if we're all the way at the top here on this sync, we don't want to pick up the second or third, mint or swap, burn or swap. We want to pick up the one right afterwards, which, could be any one of them. And that basically keeps them nice and close in a pair like that. And then when the next sync happens, it fires their handler and we can look for the one after it again. So that's really important checks to do, see how you can check it. Sometimes you need to start the for loop and go from the bottom up. Sometimes it's fine to go from the top down, but these are all sorts of decisions that you need to make, and they're case by case. So we check that the log index is the next log index after the current one. And we also check, obviously, that it is the same as the address where the event is being emitted from is the same as the sync's event.address, which essentially makes sure that it's coming from the same pool, right? And obviously, this would satisfy the check, but it's always nice to have extra checks in because I've been dumbfounded by some weird edge cases. So then we start checking against the topic 0. So you can see here, topic 0, I put in my string, this is the mint, and we go from hex string to bytes. And if it gets into that block, then we can start extracting some of the value. So one thing to note, doesn't matter if there are index topics on that event on the log, the index topics will always come back as bytes or a byte array actually. So you can see here, it's a bytes array, even though it is an index topic. Both of these are index topics. And then if there aren't any more index topics, then it'll just essentially give you this blob of bytes, and that blob of bytes is the data. And that is essentially everything else, right? So looking at this, if this was, see this data, so essentially this data, if I turn it back to hex, would come back like this, right? And this is essentially what you're dealing with in that log, right? If you're iterating through it on the receipt, this is what you're dealing with. So this is where it gets a little bit more tricky, and there isn't like a, I guess there could be some extra functions which could essentially allow it to apply for everything. But what you need to do then is essentially try and figure out how many different parameters are in this data, and you will essentially remove the 0x and divide the rest by that number, and then you know how many to move. Essentially, the important part to know is that if you go 64 from the first, that is your first data point, and then if you go 66 from the next, if you go 64 after the 0x, that's your first data point. And then another 64 is your next data point, another 64. And you essentially just need to grab those from the bytes, and you can then convert them to a big int, convert them to an address, whatever you need to do. So that's how you actually get the data off this log, once you've identified which log is the one that you want to deal with. So you can see here in the mint, what I'm doing is I am also grabbing the transfer event that's before the sync. So I'm directly grabbing the transfer event, which happens just before the sync, because this mint happens just after the sync. And I'm grabbing some information like the to and the sender of that transfer event. And then I'm getting the liquidity, the amount 0, and the amount 1. Now, this event will be viewable, and it will be verified on Etherscan, but it doesn't matter. It will still come back as data, and we still have to break it up. If someone builds an ABI decoder, ABI decoder function, awesome. I'd love to have that, but it's also nice to learn along the way. And then we just essentially, after extracting all the data, we just pass it into what the mint would do in the mint handler, right? And that essentially gives us the ability to remove a whole event handler, which obviously increases 60. And then you can see here that I'm trying to match, I'm trying to match on burn. This is the burn, doing a similar sort of thing where I'm extracting some data. I'm also iterating over the whole array again to find a specific transfer event. And then lastly, for the swap, very simple. I match on the topic 0, extract the data, pass it into the swap function. Now, the functions to essentially, I found this function by searching inside of subgraph development channel in the Discord, and I think Sun Tzu posted it like ages ago, like how to convert a hex to a big int. So I just shamelessly copied that and tested it, and I was like, okay, cool, it works. So I'll post it here, I'll post it somewhere else if anybody wants it, but yeah, that's how to convert a hex to a big int. Obviously, remember, if it has the 0x on the front, if it's the first part, that 0x needs to be removed. The hex should be 64 characters long. And then getting the address from the bytes is, you just need to add those leading zeros back, so the 0x back, to make it 64. 66, and then you essentially do a substring of 26 to remove the leading zeros after the 0x, because an address will be like so. Let's go back to decimal. You can see here, this is an address, and you can see that there's no 0x on it, and that is where the address starts. So you essentially just need to remove this portion and add a 0x to the front of it, and boom, you've got an actual address. So that's how you convert to an address. And just made a nice helper function to say, cool, pass in the large, big byte string and start here and end here, and give me back a big int from that. So that is how to use these receipt, the receipt in a very flexible and optimized way, right? So as you saw, this essentially removes the need for 3 events, and these events will obviously, removing them will increase the sync speed and also optimize the sync speed, and just optimize the running of the whole subgraph. And just want to run over some of the other data points. So after looking in the graph node a while ago, I was looking at contract address, and I was like, it's also, I think, a union type. If it's not a union type, it's either 0 address or it's set. And as far as I could tell, it's assigned with the first contract address, which is created or deployed with something like create to within that transaction. If any more are deployed or created, I think that it just still gives you the first one. Could be wrong. If anybody from the graph node or the backend team is here, would love to be corrected. And I really haven't used much of the other data points, right? So cumulative gas used, probably use that for gas tracking. The log itself has address, which is the contract where the log was emitted. It obviously has the topics array. It has the data, which we spoke about, which is that big byte string. It has the log index, which is very, very useful as well. Keep quiet, dog. And I've not used the log type, but I'll be looking into that and seeing if there's any way that I can use that as well. So that's the meat of it. Ending note, the graph will be at these upcoming events at Denver. I was there last year. It's freaking awesome. If you guys have an opportunity to go there, go to F Denver. At F London, I know that Crypto Mastery Kevin and Natasha Schlitzy will be doing a side event there, and the graph will also be at F Bucharest. So, and I know that there's a lot of other events further down the line, but these are the closest ones. So, thank you for your time. If you want to apply to the Graph Builders DAO, scan that QR code now or go to BuildersDAO.tech, and you can apply and read up a little bit more about what we do.
Awesome. Thank you so much, Mack. That's super great. Do you have this transaction receipt usage like posted on GitHub? I don't know if I missed that. If you posted it somewhere, if you plan to.
I will look if I've got some repositories that have it in. I think I've got like a couple ones that are public that I can share.
Awesome. Yeah, we can include that in the YouTube. Uh-huh.
Yeah, unfortunately, I can't share the Uniswap one just yet, but hopefully in time that will be shared. Still there.
That's great, man. Really cool. Really cool use case, and yeah, it's awesome to see what you guys come up there at the Builders DAO. You guys are awesome. Yeah, so I guess, does anyone have questions about the transaction receipt stuff or anything from Mack? Feel free to pop them in chat. Okay, well, while we're waiting for Jürgen, okay, so there's one question from Jürgen. What kind of speed improvements did you measure? That's actually just a great question. I think in general is like, you know, I think we obviously care about the indexing time, stuff like that. Did this spec it at all? What kind of thoughts can you give there, Matt?
I'm going to defer to Derek because he's the one that will actually have these numbers. I'm not sure, Derek, if you have them. I'm sorry if I'm putting you on the spot.
You're always welcome to put me on the spot. In terms of benchmarking on this one, we haven't yet completed the benchmarking for V2. I can tell you that just with Uniswap V2 specifically, they've got 150 million swaps that have occurred on chain. So that's a lot of transactions to sit through. And I think the database size, unpruned is getting close to like 800 gigabytes. So that's larger. That one subgraph is larger than most Cosmos chains, right? And so we're very excited to get this one synced to the chain head and be able to inspect what does the overall DV size look like. What was the time it took to get there? But just as a comparable datum, I believe V2 typically takes around 3 months to sync from the start block. And so we just got this one deployed fairly recently. So we're not at the chain head yet, but we'll be able to release some benchmark notes once we have a little bit more data.
Thanks, Derek. Cool. Any other questions for Mack or the team? Yes, Russ is great. Definitely something that obviously we love at the Graph. So there's really some cool stuff for that. So yeah, okay, great. So I appreciate everyone coming on today. If you guys have any more questions, feel free to pop them into chat. Again, Mack, thank you so much for coming, and really appreciate you doing that last minute. And we can hang out here. We'll keep the office hours open for the next 30 minutes. So if anyone wants to just hang out and chat, but we'll kind of end the recording. But I look forward to seeing you guys next week. I believe next week we're going to have hopefully Thomas from the BuildersDAO talk about substream powered subgraphs, talking about speed improvements. That should be pretty awesome. So that will be good, and I hope to see you guys next week.
Thanks, Kevin.